She wheels around without warning and rakes her horn across his shoulder, hard enough to draw blood. He staggers back, bellows, and does not follow. 3 hours later, he is trailing her again, 20 feet behind, matching her pace step for step. This goes on for 18 more days. 18 days of charges, retreats, blocked paths, and a low, almost pitiful whining sound coming from an animal that weighs as much as a pickup truck. And even after all of that, even after he has done everything right, there is still a real chance nothing happens. No pregnancy, no calf in 16 months. Because for a female white rhinoceros, wanting to mate and being able to conceive are not the same event, and the gap between them has puzzled scientists for the better part of a century. That is the strange, uncomfortable truth sitting underneath one of the most powerful land animals on Earth. A white rhino bull can weigh over 2 tons, can kill a lion with a single upward hook of his horn, can flatten an acacia tree just to prove a point to a rival. And yet none of that mass, none of that raw force guarantees offspring. Somewhere inside a 5-year-old female's reproductive system is a switch that has to be thrown in precisely the right way, at precisely the right moment, or the entire 18-day campaign was for nothing. By the end of this video, you will understand exactly what that switch is, why it fails so often that it became a full-blown conservation crisis, and why the fate of an entire subspecies now depends on scientists doing artificially what a 2-ton bull cannot always manage on his own. Start with the animal outside the drama. A white rhinoceros spends most of its life alone. Adult bulls hold territories of 1 to 3 square miles, which they mark obsessively. Dung piles scraped and re-scraped into signposts, urine sprayed backward in a fine mist onto bushes at nose height for any rival to find. Females drift through these territories in small, loose groups with their calves, grazing up to 70 pounds of grass a day through lips built wide and square for cropping, not browsing. Outside of mating, a bull and a cow might occupy the same patch of ground for weeks without more than a passing glance. Rhinos are not social animals. They are neighbors at best. This solitary baseline matters because it means the courtship that follows is not an extension of some existing bond. It is 2 enormous, heavily armed strangers negotiating something dangerous from a standing start. The first complication begins before the female even shows interest. A territorial bull only mates once or twice a year, and only within his own ground. Subordinate males, pushed into marginal territory by bigger rivals, rarely mate at all. So step 1 of reproduction is holding real estate, and holding it means fighting for it. Bulls contesting a boundary will walk parallel to each other for long stretches, horns lowered, sizing up mass and horn length before a single blow is thrown. Most confrontations end there, with one animal backing down. Some do not. Horn wounds to the flank and hindquarters are common among territorial males, and a horn hooked upward into the abdomen can be fatal. A bull who loses his territory does not just lose ground. He loses his entire chance at fatherhood for that season, sometimes for years. So the first cycle of risk is already brutal, and it happens before any female is even involved. Detecting that a female is even worth pursuing is its own small drama. A bull cannot simply look at a female and know she is receptive. He reads her urine. When a female approaches, he lowers his head, curls his upper lip back in a grimace called the flamen response, and draws air across a specialized organ in the roof of his mouth that analyzes the exact hormonal content of what she has just left behind. Only then does he commit. The female is not passive in this either. She produces a distinctive whistling call, sometimes described as sounding like she is blowing bubbles if she happens to be near water, and will spray scent of her own to warn other females away from the male she has chosen. So even before the 18-day chase begins, Both animals are already broadcasting and interpreting chemical and vocal signals most human observers standing 20 feet away would never notice. Once a bull has ground and a receptive female wanders through it, the second cycle starts. And this is the one people find hardest to believe. Courtship here is not a dance, it is a siege. Researchers working in Zululand, South Africa, have tracked bulls following an estrus female for periods stretching past 2 weeks, sometimes closer to 20 days. He will not let her leave his territory. He blocks her path when she tries to cross the boundary, angles his body to turn her back, and produces a sound completely at odds with his size. A high, thin, almost childlike whine, nothing like the deep grunt you would expect from an animal built like a tank. She, in turn, is under no obligation to accept him. She charges. She wheels and slashes with her horn. She bolts through thorn scrub he is too heavy to follow into. Field guides in the Kruger and Sabi sand regions have documented courting pairs where the female draws blood from the male 2 or 3 separate times over a single week, and he simply comes back the next morning and resumes trailing her. It is worth noting how different this is from a common assumption people carry into it, shaped mostly by footage of black rhinos, that all rhino courtship is built around the two animals clashing horns like fencers, testing each other blow for blow. White rhino bulls are, by comparison, strikingly restrained toward the females they are courting. Little to no horn jousting actually happens between this bull and this female. The danger here comes almost entirely from her, and from his refusal to leave. Sometimes the escalation goes further than anyone expects. At a zoo in Dhaka, Bangladesh, a courting bull was reportedly killed by the very female he was pursuing, gored during what should have been the final stage of the ritual. This is not aggression that ends the relationship in most cases. It is a filter. A male who gives up after one charge was probably never going to be a reliable, persistent enough mate to see the process through. So evolution, in effect, is asking her question after question until she gets an answer she trusts. Even though, once in a while, the question itself turns fatal. By the time she finally stops running, both animals have spent close to 3 weeks burning energy that neither can easily replace. And this is where the third cycle escalates from behavioral to physical. When she is finally ready, she stands rigid, legs locked, tail curled up and to the side. An unmistakable, deliberate signal. He approaches and rests his massive head across her hindquarters first, a gesture that seems almost tender, but is doing real mechanical work. At 2 to 2.5 tons, he cannot simply climb aboard the way a much smaller mammal would. He uses that headrest to gauge her stillness and her position before shifting his weight up and forward, inching along her body until the two animals are aligned. It is slow, visibly effortful, and can take several attempts before it succeeds at all. Once mounted, the pair remains locked together for anywhere between 15 minutes and, in some recorded cases, over an hour, one of the longest sustained copulations of any land mammal. For that entire span, two of the most dangerous animals in the African bush are standing still, exposed, and functionally unable to react quickly to a threat. Lions do not typically challenge adult rhinos, but young, inexperienced, or injured animals have been killed during exactly this kind of prolonged vulnerability. The act that is supposed to secure the next generation is, for the length of time it takes, one of the riskiest things either animal will do all year. Even success does not end the ordeal quickly. A bonded pair will often stay together anywhere from 5 days to 3 full weeks, mating repeatedly several times a day before finally splitting apart and returning to their separate, solitary lives. If conception happens, she carries the calf for around 16 months, one of the longest pregnancies of any land mammal, and will not be ready to mate again for 2 to 3 years afterward. In fact, before she allows a new bull anywhere near her, she has one more piece of business to finish: physically driving off her current calf, forcing it into early independence so the next pregnancy can proceed. So the fourth cycle is not a single victory. It is the start of a multi-year commitment that the pairing itself only opens the door to. A calf that will nurse for over a year, walk in front of its mother rather than behind her the way a black rhino calf does, and stay close enough that she will fight off a lion for it without hesitation, right up until the day she decides it is time to push it away for good. And then, this is the fifth cycle, the one almost nobody expects. All of that risk, all 3 weeks of chasing and charging and blood and exposure might still not produce a pregnancy, and for decades, nobody could say why. The first white rhino ever born in captivity arrived at Pretoria Zoo in South Africa in 1967, a milestone that took the better part of a century of zookeeping to reach. But that early success turned out to be misleading. By the mid-1990s, studbook records kept for decades by Berlin Zoo showed just how uneven the picture really was. More than 600 white rhinos had been captured from the wild and shipped to zoos and parks around the world, yet fewer than 500 had ever been born in captivity, across every institution combined over more than 100 years of trying. Across the decades that followed, zoos around the world imported wild-caught rhinos and paired them with proven, healthy mates. Mating was observed and confirmed again and again, and still, year after year, no calf. Some females that never bred for years developed reproductive tract pathologies that made them infertile even younger than expected. Infertility caused, in part, simply by not breeding. For a long time, the working assumption was behavioral. Maybe captivity stressed them. Maybe pairs were incompatible. Maybe rhinos needed more space than any enclosure could give. It took reproductive physiologists, using tools nobody had access to a century earlier, to find the real answer. And it was not behavioral at all. It was hormonal, and it was happening silently, invisibly, inside animals that looked completely normal from the outside. Beginning in the 1990s, researchers at the Leibniz Institute for Zoo and Wildlife Research in Berlin, led by reproductive biologist Robert Hermes, working alongside Thomas Hildebrandt, began using transrectal ultrasound to actually watch rhino ovaries cycle in real time, something that had never been done systematically before. What they found reframed the entire problem. In captive white rhinoceros females, a large share were cycling without ever actually ovulating. Follicles would grow to full, apparently mature size and then simply regress, over and over, releasing no egg at all. The estrus cycle itself turned out to be strange too. In white rhinos, it runs either roughly 4 weeks or roughly 10 weeks. With no fully agreed explanation for why individual females fall into one pattern or the other. Layered on top of that is a detail almost too strange to believe. Field biologists in Zululand found that a daughter sharing a home range with her own mother will often suppress her own ovulation entirely, apparently to avoid competing with her for the attention of territorial bulls. A fully grown, sexually mature female rhinoceros can simply decline to be fertile as long as her mother is standing nearby. That discovery opened the door to actually fixing it. If the problem was a follicle developing but never triggering ovulation, then the solution had to work on that exact hormonal step. Hermes and colleagues, along with a team at the San Diego Zoo Safari Park under reproductive physiologist Barbara Durant, developed protocols using a synthetic hormone called a GnRH analog, injected once a pre-ovulatory follicle reaches roughly the size of a large coin on ultrasound. In multiple published trials, more than 80% of treated females went on to ovulate within 36 to 48 hours of the injection, a level of precision no amount of natural courtship, however long or violent, could reliably produce on its own. The technique proved itself in 2019 when a female named Victoria at San Diego's Nikita Khan Rhino Rescue Center was inseminated using frozen semen following exactly this kind of hormone-induced ovulation. 493 days later, she gave birth to a healthy male calf named Edward, the first southern white rhino born through artificial insemination in North America, and living proof that the missing piece had never been effort or compatibility. It had been one hormonal trigger delivered at one precise moment. This is where the common assumption falls apart. Many people assume that when a captive breeding program fails, it is because the animals simply will not mate in an artificial setting, that something about being watched, fenced, or displaced from the wild switches off the instinct entirely. But that is not what is actually happening here. White rhinos in captivity mate. They court for weeks, they fight, they copulate for the better part of an hour. All the visible behavior is intact and functioning exactly as it does on the savanna. The failure sits one level deeper, in a follicle that grows and then quietly gives up without anyone, including the animal herself, showing any outward sign that anything went wrong. The instinct was never broken. The biology underneath it was. The stakes of finally understanding that mechanism are as high as conservation gets. The northern white rhinoceros, a separate subspecies, was pushed to the edge of extinction by decades of poaching, and the last known male, named Sudan, died in Kenya in 2018 under armed guard. Only 2 individuals remain on Earth today, both female, both his descendants, both physically incapable of carrying a pregnancy to term themselves. The subspecies survives only as frozen sperm in liquid nitrogen and a small number of viable eggs harvested from those last 2 females. Eggs that can only be collected at all because scientists now understand precisely how and when a rhino ovary will actually release one. The same Leibniz IZW team behind the ovulation research has spent years turning those eggs into embryos in a lab, then attempting the next impossible step, implanting a northern white rhino embryo into a southern white rhino surrogate. Their first proof of concept, a southern-to-southern transfer at Ol Pejeta Conservancy in Kenya, produced a confirmed 70-day pregnancy in September 2023, a world first for the species. The pregnancy itself was lost weeks later to a bacterial infection following flooding, but it proved the mechanics worked, and northern white rhino embryos have since been transferred into surrogate mothers multiple times in the attempts that followed. None has yet carried to term. But every one of those attempts, successful or not, is built entirely on the same discovery this video started with: knowing exactly how to make a follicle release an egg on command. The southern white rhino, the subspecies whose courtship and mating you have just watched, tells the flip side of that same story. Hunted down to roughly 20 surviving animals by the start of the 20th century, strict protection and decades of exactly this kind of reproductive research have rebuilt the population to somewhere near 16,000 today, making it one of the only conservation recoveries of its scale in modern history. So the picture that emerges is not really about size or horns or which animal wins a shoving match at a territorial boundary. A 2-ton bull can win every fight, survive every charge, follow a female faithfully for 3 weeks, and still walk away with nothing to show for it, because the final decision was never his to make. It belonged to a follicle a few millimeters across, deep inside an animal that gave no outward sign of what it was or was not about to do. Nature built one of the most physically dominant creatures on the planet, and then handed the actual power over its future to something almost too small to see. Right now, in reserves across South Africa, that same 18-day chase is playing out again, somewhere in real time. And whether it ends in a calf 16 months from now, still comes down to that same single precise biological switch.